Okay, so here we are with lab number 6, percent hydration. Percent hydration means what fraction of a total sample is made of water. Pretty straightforward. Kind of like what percent of the questions on a test did you get right? What percent of whatever material we're dealing with is made of water. If we were doing this in the lab, we would be using an inorganic compound that has water molecules attached to it. And we would be measuring the mass of that sample before heating it and after heating it. During the heating process, water is evaporated, so it's the mass difference that tells us how much the water weighed, and we can figure out as a fraction how much the water weighed as compared to the whole sample, and that will tell us the percent of the sample made of water. So what we can do at home as one option to mimic that sort of experiment is bake a cake. And that's what we're going to be doing. So any standard box mix will work. You're also going to need 3 eggs, which I already broke, so you didn't have to watch that process. 1 cup of water, which I already measured, and a 1/2 cup of vegetable oil. You'll also need 2 small pans that you grease. These cost about $1 for the pack of 2 at the store. So I already greased them as well. I just used Crisco. You can get some of that, or maybe you have some at home already. And we're going to be baking the cake. But first, let me show you the formula that you're going to be following. Percent hydration, basically, what it represents is the mass of water in a sample over the mass of the whole sample, which includes the water, times 100. And that will give you a percentage that represents the percent of the sample made of water. So for our cake, what we're going to be doing is weighing the cake before we bake it and after we bake it. So the mass of water in that case is represented by the difference between the 2 masses. So you're going to say the mass before we bake it, so initial mass, minus final mass. It's going to weigh less after we bake it because we're evaporating water away. It's that process of evaporation that removes the mass, it removes the water, and we're going to be measuring how much the water weighed. That's our numerator. So on the bottom goes the initial mass. That's the mass of the cake with the water in it. So we're actually finding out the percent hydration of an unbaked cake. That's what we're going to be calculating. And you multiply by 100. So let's go ahead and make the cake, and then we'll weigh it. And I'm going to record the initial mass to fill in this equation. I'll put the cake in the oven, and then we'll cut back into the video to come up with the final mass, and I'll show you how to calculate that. So, baking a cake. I'm a chemist, not a baker, so let's follow the directions. So we have to add the cake mix, the water, the oil, and the eggs. Easy to follow directions. In a large bowl, cake mix. If you are someone who likes to bake, feel free to make any kind of cake you like. Just weigh it before and after you bake it. Probably going to end up eating it, so make something that you like or give it away. So we have our cake mix. We have our water, that's 1 cup. I already measured it at eye level. We have a 1/2 cup of vegetable oil I have to measure. So do you think the mass of water is exactly equal to the mass of that 1 cup of water? Probably not. There's probably more. There's probably some liquid in the egg as well. So we're adding our 3 eggs in addition, and we're going to beat this. It says vigorously by hand or on medium speed. So I've got a mixer, a hand mixer here that I'm going to use. And I have to mix all this together really well. Okay, that should be good enough. So we mixed our batter. Oops. Okay, so we lost a little bit. And then we're going to distribute it into the 2 cake pans. Make sure that you bake your cake in 2 small pans instead of 1 big pan, because I want to make sure that when you weigh it on your digital scale, it's not too heavy. That's important. It has to be a mass that your digital scale can read. And I really want to lick the pan. It smells good. I got a lemon cake. But I won't do that. Okay. So, set that aside. And the next thing we have to do, very simple, is just find our initial mass. So I have our digital scale that we had used in a previous experiment. And we're going to be using it several times throughout the course. And I'm going to set it flatly on the table and hit the 0 button so that it reads 0, so that you know it's detecting nothing on the surface. Now we do have 2 cake pans, so I'm going to take a reading for both, and I'm going to average the 2 values together for my final reading. You can do the same. If you have 3 cake pans, that will be better. It's always better to average 3 things together than 2. So I'm just going to take my cake and set it on the scale, making sure nothing's in the way, and it is 388 grams. So I'll write that down. I can find where I put the chalk. Get another piece. So our initial mass, trial 1, our first cake, we have 388 grams for our initial mass. And trial 2, I'm going to weigh the second cake. Let's see what we have. 353 grams. Okay, so my oven is preheated. I'm going to put the cakes in, and we'll be back. We'll weigh them once they're baked and find out how much the mass changed, and hopefully we lose some water in the baking process. So we are back. The cakes came out of the oven. I'm very proud that I did not burn them. And now all we have to do is find our final mass. So it's important to note that before you take your final mass, make sure that the cake has cooled completely. I just left the house to do other things for about 2 hours, so it's definitely cool. Why is it important to let the cakes cool? It's not so much because of the heat, but because of the fact that when they're warm, the water is still evaporating away. So you want to let them completely cool so that as much water as is going to be removed from the cake is removed. So let's weigh our 2 samples. Another thing that I should have said in the first video, hopefully maybe you're watching both of them together before you make your cake. It would be smart to mark one pan or the other so that you know which is trial 1 and which is trial 2. I know that this was my trial 1 and this was trial 2, but that was just sort of keeping my eye on it. You may want to mark the pan in some way. Put a little hole in one of them or something like that. Okay, so the first cake, again my scale is 0. Now it weighs 345 grams. So originally it weighed 388 grams. So the final now weighs 345 grams. So we can see here that we lost about 43 grams of mass. That all must have come from water evaporating away from the cake. So what we're going to do is take 43 grams and use that as our numerator, and we're going to put that over 388 grams. That was our starting mass. So we'll find out what percentage that makes up. Now let's find out what the second cake weighs. 311. So this cake started at 353 and now it's 311. So this one also looks like it lost about 42 grams. And that all came from the water that was evaporated away. So for our second trial, we'll put 42 on the top, 353 on the bottom, multiply by 100, and be able to determine what percentage of that original mass came from water. And I'll do that on the board in just a minute. So something also to note, in the lab experiment, if we were in the lab and we were heating our sample to get rid of all the water, that would be a very accurate representation of percent hydration. However, we know that cake generally tastes moist and we don't want a completely dry cake. So this percent hydration is really sort of, an idea, percent hydration. We're not removing all the water. We're removing some amount of the water. So percent hydration you have to take with a grain of salt in this lab because we're not removing all of the water from our sample. If we did, we'd have to completely burn the cake and no one would want to eat it. So we're just going to bake it as normal, remove the recommended amount of water, and then determine percent hydration as sort of a ballpark figure. What you're going to ultimately do after you calculate your percent hydration, you can average your samples together. Again, if you have 3 cake pans and you can get 3 samples, that's even better for an average. And then you're going to compare your result to what I have. And what we're going to consider your theoretical value is what I come up with here today. It's not necessarily the be-all, end-all correct value, but it's a reference value for you to use. And so I want to see all of your percent error calculations done as compared to whatever we come up with here in this video. Okay, so here we go. We're going to show the 2 trials separately. So I'm just going to erase this part here. Ultimately, we're looking for the mass of the water over the initial mass. Actually, I'll just do this. I'll just fill it into the formula. So for trial 1, our initial mass was 388 grams, and our final mass was 345. We're going to put that over the initial mass of 388 and multiply by 100 to get our final answer. So let's solve that equation. Let's do that together. 388 minus 345. You can probably do it in your head. 388 minus 345, just like I said before, is 43 grams. So first thing you do is always solve within the parentheses first, and that's where we come up with our mass of the water on the top and the mass of the initial sample on the bottom, just like you see here. Water over sample, that's where we come up with that initial minus final. So we're going to do this division next and multiply by 100. Let me just write this so that you can see it more neatly. So this times 100 is going to be our percent hydration. So we have 43 divided by our initial mass. We come out with 0.111. So how many significant figures should we keep? We have 2 on the top, 3 on the bottom. Let's keep 2 all together. This 100 is considered an exact number, so don't consider it into your determination of significant figures. So we're going to keep 2 significant figures, which when we multiply our 0.11 by 100, that is an 11% error. Sorry, 11% hydration, not percent error. That's the next calculation. So we found out percent hydration in this experiment was 11%. What that really means is we lost that much water when we baked the cake. In reality, the percent hydration in the initial sample is probably higher because when we bake a cake, we don't remove all of the water. But this is just an example for you here today. Okay, now for our second trial. For our second trial, let's fill in our numbers. We started with 353 grams. and we ended up with 311. So we're going to show initial minus final over initial. 353 minus 311 over 353. And again, to solve the equation, we want to solve within the parentheses first. So 353 minus 311. I was right, 42. Good idea to check your math. And now that is the mass of water that we lost over the mass of the initial sample. So if we're considering the mass of water we lost as the total water in the sample, we divide by this number, multiply by 100, and we come out with our percent hydration. So, as a fraction, 42 over 353 is equal to very similar to the other one, 0.1189. So we're going to keep two significant figures. We'll call that 0.12. So if this is equal to 0.12, we multiply by 100. That moves the decimal place to the right 2 places. And now we end up with 12% hydration. So for our trial 1, we came out with 11% hydration. Trial 2 was 12% hydration. Those are the 2 values we found. So, to find the average, we can add 11 plus 12, divide by our number of samples. The average is right halfway in between the two of them, 11.5% hydration. However, can we really be more specific in our average than we were before? That's kind of a debatable question. The 5 in this textbook that you're using usually rounds up. So for the sake of you needing a theoretical value to compare your results to for your percent error calculation, I'm going to decide to round the 5 up, and we're going to use 12% as our percent hydration. So 12% water is what we've determined for our cake. So everybody write down 12%. If you're baking a cake for your experiment, you're going to compare your number to this number. And I'll show you how to do that right now. So that next calculation that you need to do, it's called percent error. It's comparing your value to something that's commonly accepted. So for this class, we're commonly accepting 12% as our percent hydration for a cake. So the percent error is actually very similar to percent difference. Percent hydration is also similar, what we just solved. We're finding a fraction and we're multiplying by 100. It's based on differences, subtracting one number from another in the numerator and putting it over a denominator. So you're going to put your measurement, which is your experimental percent error, that's your measurement, minus, we're going to call it the theoretical percent hydration. And again, this is the number we found here today, theoretical. And we're dividing it by the theoretical percent. And multiplying the whole thing by 100. So let's do an example. We know that the theoretical percent hydration is 12%. We just found that here today. So I'm going to fill in an example for you. Let's say you do this experiment. And actually maybe you bake your cake longer than I did. And you come up with 15%. So our percent error is going to be 15 minus 12 in the numerator, that's 3. And we can actually do this one in our head. 3 over 12. What's 3 over 12? That's 1 over 4.25 times 100. Your percent error would be 25%. That's actually quite a lot. So we're hoping for a percent error closer to 5%. However, depending on your unique oven, the unique cake that you bake, whether you undercook it or overcook it, we're going to see a whole range of percent errors in this problem. So you're going to solve this just like I did here, using 12 as your theoretical percent hydration. There's another example that you could do for percent hydration where actually we're getting rid of almost all the water in the sample, unlike a cake where we're not really getting rid of all of it, but we can still solve the same type of equation. If you pop a bag of popcorn in your microwave and weigh the bag before and then after you pop it, you'll be able to subtract those two numbers, put it over the initial mass to find the percent hydration. I actually don't own a microwave, but if I can get my hands on one, I will make a video showing that. Otherwise, it's just the same procedure. Weigh it before, weigh it after, and do your calculations. So, happy calculating. Make sure that you submit your data sheet, a clear image of it, as well as a video or a picture of you doing this experiment. And then enjoy your cake.